Welcome back, ladies and gentlemen. Dr. Robinson here again, and we're going to continue our studies. This time we are talking about the counting principle and compound probability. This will be a two-part series. We'll first deal with the counting principle because in order to deal with compound events, you really need to know that first. So, there's my picture. You know my channel name, Dan Robinson, PKMS. So subscribe, so help us to get to 1,000 subscribers. All right, here we go. Compound event consists of two or more events. An independent event is the occurrence of one event that does not affect the probability of the other event. So it's totally independent, does not care what the other event is doing. So it's on its own. To find the probability of two independent events, you multiply the probability of the first event times the probability of the second event. A dependent event is if the occurrence of one event affects the probability of the other one, so it's depending on the other. You might have heard in science independent and dependent variables. So think of that as you talk about independent and dependent events. But we need to talk about the counting principle, or the fundamental counting principle, in order to deal with compound probability. So let's find out what we mean by the fundamental counting principle. Well, the rule for finding the number of possible outcomes, that's what it really is. It states that if you have m possible outcomes and another independent event has n possible outcomes, then there are mn or m times n possible outcomes for the two events together. So what do you mean, Dr. Rob? Well, let's get into it a little bit deeper. When we're talking about all those possible outcomes, we're talking another way of saying sample space. That's the set of all possible outcomes. For example, if you have a dice cube, a die, it has 6 numbers on it. Those numbers are 1, 2, 3, 4, 5, and 6. Those are all of the possible outcomes that can occur when you roll that dice cube. So let's take a look at an example here. We have Najee. She has 2 pairs of slacks. There they are there, jeans and black jeans, and 3 blouses, yellow, green, and yellow with a red stripe. How many different outfits can she wear consisting of 1 pair of slacks and a blouse? All right, so she's got to choose from what she has, and she's going to put on just one. Let's underline that. 1 pair of slacks and 1 blouse. Well, she has a lot to choose from. She first can choose her blue jeans, and she can choose from any one of these 3 tops with the blue jeans. So that's 3. So she'll be using the blue jeans a total of 3 times with those 3 different tops. But she's not finished. She also has a different pair of slacks, and she can use those same 3 tops again with that pair of slacks, her gray jeans. So let's take a look at what we got. We just listed and drew all the different combinations that you have, and notice they're the same jeans, yes. So there are 3 over here with the blue jeans, a total of 3 different tops. So there's 3 there. Plus she has the gray jeans, 3 of those same tops. So she has a total of 3 plus 3, 6 possible outcomes consisting of 1 pair of slacks and a blouse. So the blouses made the difference in each occurrence because it's not the same, it's different. Like the yellow top is the same as this yellow top, but the jeans are different. So that's what makes it different. Okay, so each time they use the shirts but a different pair of jeans. So the jeans made the difference. So 3 plus 3 is a total of 6. So Najee has a total of 6 different outcomes. And I drew it this way. So I have the blue jeans here, and that way you can see each one of the sets that she wore for those days. So here's the gray jeans, and she has, again, those same tops, but the gray jeans. So she has a total of 6 outfits that she can wear throughout the week to school. All right. Now, notice I drew with those lines there. When you draw a picture of that type of sample space, well, possible outcomes, that's called sample space. So it's a tree diagram that we're talking about. When you draw a picture like that, it's a graphical illustration of sample space or the total possible outcomes. So I've seen tree diagrams that go top down, vertically speaking, or sideways like branches of a tree. So sometimes your tree will look like a pine tree or a Christmas tree. Sometimes it'll look like the branches of a tree. Okay, so that's a tree diagram. It's just a graphical illustration of sample space. But we're talking about the counting principle. And let's apply that to Najee's situation. If you remember in the problem, Najee had 2 pair of pants and she had 3 different outfits. Well, the counting principle tells us to multiply the different items and we'll get the total possible outcomes. So 2 pants times 3 shirts equals 6 different possible outfits. So that's why Najee had 6 different outfits based on the counting principle. And it's a lot easier to do that way than drawing out the tree diagram or listing all the different possible outcomes. So you might like that method better. Counting principle, very handy. So there's the technical definition. If you want to get into that and read all that, go right ahead. I just want to go to the last bullet. Tree diagrams provide us with a visual representation of the constituents of corresponding expressions. So it looks like a family tree. So here's another example of Najee. See if you can figure it out. I'll let you stop the tape for a few seconds and see if you can figure out, because this time she has 2 pairs of slacks, 3 blouses, and 2 pairs of sneakers. Now she has sneakers. All right. How many different outfits can she wear consisting of a pair of sneakers, slacks, and a blouse? So see if you can figure it out. Okay. Hopefully you got the answer. I'm going to reveal it. If you said 12, you are correct. How'd you get that, Dr. Rob? Well, I'm going to draw a picture right here of what we had previously. There's my picture, her jeans. They're the days I represented, the outfits I represented. But now I'm going to add on a third layer to the jeans and outfits. She has a choice of the gold sneakers or the blue and white sneakers to wear with her first outfit. So that's 2 additional outfits that she can wear as opposed to just the one. So there's extra 2 there. And when she wore the next outfit, uh, she has the choice of wearing 2 more different sneakers that she could wear with that green shirt. So that's another 2. And the third option we had, now she has the option of wearing her different color sneakers, again, the gold ones or the blue ones, to match with her yellow and striped shirt. So there are the 3 options that we have. But now notice it adds an extra layer to it because of the sneakers, because she's wearing a different color pair of sneakers, and it's not the same outfit because the sneakers match with something different on her outfit. So now instead of having 3 different outfits, we have 2 plus 2 plus 2 equal a total of 6 with this pair of blue jeans. But guess what? Najee also has the other pair of jeans, her gray jeans, to match. So if she wears her gray jeans, she still has the 2 sneakers now. So there's 2 more with the gray jeans for the first outfit. And she has 2 more with the second outfit, which the gray jeans. So she can wear again her 2 different sneakers. And with her last outfit with the gray jeans, she has another 2 different outfits that she can wear. So 2 plus another 2 plus another 2 gives us 6 again. So she has 6 more outfits with the gray jeans. So if she has 6 outfits with the blue jeans, 6 outfits with the gray jeans, if we add that up, Najee has a total of 12 outfits. Is correct. There is the 12. So hopefully you see the picture a little bit better, but I'm going to show it to you a lot nicer than that. So that way you can see the outfit with the sneakers. So here's her blue jeans on the left side. Here's the first outfit with the yellow sneakers. Here's her second day's outfit with the yellow sneakers. And here's the third outfit with the yellow sneakers. And here's where she has the same first outfit, but using her blue sneakers. And there's the green shirt with the blue sneakers, her second outfit, her third outfit, uh, with the blue sneakers. So there are the 6 outfits she has with the different color sneakers. So you can see the 6 a little more plainly here. And here are the gray jeans that she has with the yellow sneakers, the 3 up there and the 3 down there. So, and that's with the gray jeans. So there's 6 over here and 6 over here, her total of 12. So I hope you got that question right. And now you can see it better. But let me use the counting principle just to make sure. We have 2 sets of pants, jeans, and she has 3 shirts, but now we're introducing 2 sneakers now. So 2 times 3 is 6, and 6 times 2 is 12 different possible outfits Najee can wear. So nice going, Najee. So I hope you understand what's going on. If you're not sure, rewatch the video, write down your questions and bring them in, and I'll be glad to answer them in class. So let's move on a little more. So now we have find the total number of possible outcomes when you select one color of wallpaper and one color of carpet. So you're getting wallpaper and carpet for your living room. Well, how many different color wallpapers are there? I should count that up. 1, 2, 1, 2, 3, 4, 5, 6 different wallpapers. I need to know that. And how many different carpets do we have? Carpets. 1, 2, 3, 4, 5. 5 different carpets. And if you remember the counting principle, you should know what to do in order to find the total possible outcomes. And if you said multiply, you're right. We're going to multiply 6 times 5, and that'll give us the total possible outcomes of 30. So there are 30 possible outcomes that we can match up. 30 with that, Dr. Rob? Are you sure? Well, let me show you. Let's go to the next page. Let's use the counting principle. Counting principle said we had 6 different wallpapers times 5 different carpets, so that gives us 30 possible outcomes. So let me get a graphical illustration here. Here's my tree diagram, part of it at least. So I put my wallpapers on top because wallpaper color or rectangular in scope, and the carpet rugs. I have round little carpet rugs. There's the green one, the orange one, the red one, the purple one, and the blue one. So there are my 5 carpets, and there are my 6 different color wallpapers. So the first wallpaper is yellow, and look at the different color carpets that can go with the yellow. The green one, the orange one, the red one, the purple one, or the blue one. If you count that up, I have 1, 2, 3, 4, 5 to go with this particular yellow. But guess what? I don't have to use yellow wallpaper. I could use red wallpaper. You can use red wallpaper? Yes, because that's one of the choices there. I can use red. So what if I use red? Well, count them up. 1, 2, 3, 4, 5. Again, I have 5 different colors that I can use of carpet with the red wallpaper if I want to. Hopefully you'll see where this is going. I'll get the blue wallpaper. And guess what? 1, 2, 3, 4, 5 again. And I got 5 more with the blue wallpaper. And if I don't want to see the blue, maybe I want to use the green wallpaper. And I still have another 5. So hopefully you're seeing every time I choose a different wallpaper, I have 5 options all the time, another 5. And when I get to the orange wallpaper, and let's get the orange down here, and notice again, I have 5. So 5 different wallpapers. that over there. Now, I had 5 with the yellow, 5 with the red, 5 with the blue, 5 with the green, 5 with the purple, and 5 with the orange. If I add those all up, that would give me a total of 30. So I have to add all those up. But Dr. Rob, I thought you were supposed to multiply. No, 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 you're not supposed to multiply. We counted, we showed you a tree diagram. Each time there were 5 different ones. If you want to multiply, well, this is what you do. There are 6 different wallpapers, and there are 5 different rugs, which is a little faster than adding them up and drawing out all those lists. Now you can multiply those. That'll give you the 30. Okay? So that's a good one. Let's try again. Maybe you didn't get it. Find the total number of possible outcomes when you select, again, one color of wallpaper and one color of carpet. So here we got yellow, green, red, blue, and orange, and wallpaper, and we have yellow, blue, orange, and purple carpet. See if you can get the answer. So pause the videotape and see if you get the answer this time. Okay, I know that was fast because I'm sure you got it. Let me release the answer. If you said 20, great job, because there are 5 different wallpapers and 4 different color carpets. So 5 times 4 is 20. Here's one more for you. So if you got this one, then you're an expert and you're on your way. So figure that one out. I'm not going to release the answer till class time. So you come and tell me. So I hope you're doing well with this. And if you're not, just rewatch the video and write down your questions and bring them in. I'll be glad to go over this in class. So next time we talk, we'll go to part 2 of this, dealing with what's called the compound events, because again, as I said, you cannot do the compound events until you deal with the counting principle, because it definitely helps. So this is Dr. Rob. Remember, check out our videos on YouTube. My channel name is Dan Robinson. Subscribe to our channel. Help us get to 1,000 subscribers. And write a comment if you like what we're doing. If you write me, I do write back. Dr. Rob signing off. Take care.